proteins that are part of disease expression, that if they're present with that disease, the drug can also interact with in some way and create either positive or negative, for that particular disease. So the interaction can be even more than what we've seen. Some of these gene-drug response associations have been studied for several different proteins. I've listed them. Human leukocyte antigen gene, HLA. I know if you've had science classes, you've heard about HLA, you've had HLA before, human leukocyte antigens, and there are a wide variety of those things. So that's a very common one. Factor V and prothrombin genes, genes for channel proteins, genes for apolipoprotein E, just as some examples. An example of it, what can happen. There is a drug used to treat AIDS called Zeogen, however you want to pronounce it, abacavir, nucleoside reverse transcriptase inhibitor. There's a whole group of drugs like that used to treat HIV and AIDS. And if a person is receiving that drug for AIDS, and they also happen to have HLA, human leukocyte antigen B5701, they're at an increased risk for a hypersensitivity reaction that is a bad body-wide skin eruption that also has fever, malaise. It's a pretty significant event. So much so that the genotype for that is screened for before you use that drug. I've got the picture up here right now so you can see that's pretty dramatic. 5 to 8% of people get it within the first 6 weeks, so it's a thing that can be predicted. That's one that we do know about, and it is well known that it is now part of the drug labeling for that product, and there is a test that you can screen for to see if you have that, because if you have that, then you're not going to use that drug. And most of these nucleoside reverse transcriptase inhibitors are usually used in combinations now. There's not usually single drugs, there's multiples that are used, and there are multiples to choose from, but this would be one way to help you limit your options. But this is a case where you use a drug in a person that also has this HLA complex. That combo, through an immunologic mechanism, leads to this hypersensitivity reaction. Now on page 14 and page 15 and on page 16, there are different medications that are there, and these are ones that have pharmacogenomic labeling. So this is not just in the realm of science. If you pick up these medications or look at information about them or pick up the bottle, there is information that is FDA required about pharmacogenomic testing and what happens if you have that pharmacogenome and you take that medicine, it's a risk. So most of these risks that are put on packages deal with adverse reactions. That we don't want you to have this kind of adverse reaction. You take this drug, it's a safety thing. I don't know of the labeling to predict positive response, and we're going to talk about that in a second here about the ethics of exploring. Are you a responder, non-responder, or what does that mean, for resource use? But for toxicities, it's in there, and that's one of the goals of pharmacogenetics. It was not only to increase responsiveness and positive outcomes, but also to minimize toxic outcomes. So here's some that are known. And you can see, if you look at them, most of them are immunologic drugs, or and there's some chemotherapy drugs, but it kind of ranges across the board which ones have labeling. Okay. So that we just finished covering the different targets where genetic variations can happen. Receptors, transport proteins, channels, post-receptor, proteins, that make things work inside the cell, and also other genes and proteins that are associated with the disease. If you take a drug and that person has that other genome or allele for that combo can be a problem too. So there's all the ways that drugs can cause problems. So let's look at just a little bit more about what does all this stuff mean. We kind of covered all the science part of it. So now let's think about what would you actually do with this? What would be the application for it? Well, the first thing is kind of obvious, that if you understand the genetics of any given disease, you might be able to make drugs that would target that genetic component, whatever genetic component there is, to positive benefit. if you knew the genetic origins of a disease, then you can make treatments that would modify those genetics. And we already have examples of that in society even right now. Now, they're expensive, but it doesn't mean that it can't happen. Okay, look up the top of page 17. Here's an example of a drug that has been developed based on our genetic understanding of an aspect of a disease. I know y'all haven't probably had this yet, but human epidermal growth factor receptor 2, HER2, human epidermal growth factor 2, secondary to a gene amplification. That means it's just more of it. It's just more prolific within certain people. That's a 20 to 30%. It occurs in 20 to 30% of people with metastatic breast cancer. Okay, so if you have breast cancer and you have HER2 amplified, like would occur in 20 to 30% of people, that's a risk for a poor outcome. There's less survival if you have that HER2 part of it. It's been known and discovered that that's a risk for a more significant outcome. It means the cancer cells grow faster, they can spread more, and there is a drug that's been developed called Herceptin. Okay, it's one of those monoclonal antibodies, trastuzumab, and all these MABs. Okay, all the monoclonal antibodies will end with an AB, usually MAB, NAB, but it's an AB or antibody at the end. So that Herceptin is a recombinant monoclonal antibody, targets HER2, and it blocks HER2 stimulated growth of cancer cells. So we know that genetically those people are at higher risk for spread of disease, and this drug actually slows it down. So when Herceptin is combined in with the other therapies for breast cancer, it should lead to a better prognosis and or a longer lifespan for that person. So there's a case where genetic study of a disease has led to a medication that has led to a better outcome. So that's just one example. Okay, gene therapies. Have y'all, has the term gene therapy, phrase gene therapy been used so far in this class? Okay, let's just give you a definition, of gene therapy. Okay, gene therapy is where you treat or cure disease by altering gene expression. You do things to get inside the genetics of a person so that you can change how that genetic component works. It doesn't express itself. It blocks it, or alters it in some way so that you don't get the bad thing that happens when the genes do what they want to do without anybody getting in their way. Okay? There's two different types of gene therapy that we look at. We look at gene therapy for inherited diseases, and we look at gene therapy for acquired diseases. The distinction is an inherited disease is used to correct or repair genetic defects permanently and thereby restore normal function. Things like, like Huntington's disease, just to go off the example.
Muscular dystrophy is a big one.
Yes,
and cystic fibrosis.
Yes, and those things are just debilitating. They're not going to go anywhere unless you do something with them. So that would be an inherited disease that the person could have, and what you're trying to do is correct it so that it never happens. There's all kinds of disorders of inborn metabolism where you can do genetic manipulations. So if the person, they're just not very common, and there's really, honestly, from the drug industry perspective, not a lot of incentive to do it because it's expensive to create these things, and if you're going to put all that money into it and your market is just tiny, there's no incentive. Now, idealistically, you think, why don't we just take care of problems like that? But there's a practical part of it too. In an economy that doesn't have all the money in the world for every single thing, you end up making choices, which we're going to talk about the ethical decisions that come into knowing things about people's bodies, what you're going to do with it. Okay, but for an acquired disease, and I gave examples of hypercholesterolemia, hypertension, cardiac disease, maybe even an infection that leads to some derangement, of body function. That's an acquired disease. You're just trying to cure the disease by targeting the pathogenic processes that unfold because you have that. The problem with gene therapy is that how do you get the genes in there and how do you manage it? Okay, I've underlined the word exogenous genes. You can also call those transgenes. Those are genes that we're making out here that we're trying to put in the body. Okay, transgenes or exogenous genes. They can either put into somatic cells, body cells, or they can be put into germ cells, which are reproductive cells. The issue there is that if you do somatic cell insertions and change the genetics, that's just in the individual. They can choose to have that done to them. It's my body. It doesn't impact anybody else's. When you start altering genetic material inside germ cells, then it's not just you, it's whatever you can pass along. Because once you interfere with germ cells in a body that is capable of reproducing, that gene change and that gene insertion can be submitted through transmission. And then you start getting into the issue of changing the future for an unborn person in some way that may infringe on rights. I know this, I'm kind of getting lawyery at this point, but that is one of the big issues with insertion of genetic material into germ cells. Okay, somatic cells, your choice, your body is going to do what it's going to do. You go into germ cells, and law has a different view of that. Okay. I give at the bottom of the page an example of the first gene therapy trial. It's a gene for an inherited disease. It's those people with adenosine deaminase deficiency. B and T cells don't develop. It's autosomal recessive disease, and it causes severe combined immune deficiency syndrome. You've all seen movies about the boy in the bubble. Children that are so prone to any infections that they put them in sterile environments and they can't let people touch them or get involved with them. Well, that's a terrible disorder to have, and they have discovered genetic background for that. And they've had 2 people in the trial, and it has not been overwhelmingly positive. It doesn't cure disease, but it makes it a little bit better. So that's an effort. That was one of the first efforts to do gene therapy, was in people with this immune deficiency syndrome. Okay, but that goes back to 1990s. Okay, so it's not that far, ago. Now, up into the 2000s, we now have almost 2,000 different gene trials that are going on, and the results will start showing up. And they're going to start showing up within your generation and your practice life. But again, they are complex things, and they take time before you can get results back on those. Mostly they haven't done that well yet. And mostly it's because our technology and our techniques have not yet been perfected for how best to do this. The biggest obstacles listed, there are 3 obstacles, and the most important obstacle that we're dealing with right now is inefficient gene delivery to target cells, which would make sense to me. If you figure out what the genetic insertion ought to be, how do you get it where it's supposed to go and then assure that it does what it's supposed to do? It's a trick. I mean, if I'm sitting here thinking, how do you put genes into somebody? You can't take a needle and just go, it's not going to work like that. Tiny needles, and then how many cells you have to put in? 1, 2, a bunch? I mean, just think about the technique of it. So, what's that? Somebody said something? Were you saying something, Jenna?
You're just cute.
You are. No problem.
I was like, just the things you think of, like,
just the way
like at night.
Think like me and you'll be like me. Okay. Who knows what that'll turn into. But the biggest problem is getting genes in and then getting it to express properly. The two biggest ways they've been using genes in is actually through viruses. Okay? You put the new genes on viruses, and then the viruses go all into the body and put it where it's supposed to be. So, I mean, when you're counting on a disease to help you cure a disease, think about it. You're making viruses and getting them into people, putting them into people. There's 2. There's the retroviral gene delivery, which integrates into human DNA. Most commonly used to use retroviruses. The other is the adenoviral gene delivery. They don't integrate, so they are only active and present at the time that you put them in. So that one is less lengthy, okay? You kind of want ones that are going to hang around and proliferate enough to change enough genetic material that the outcome, changes. Non-viral delivery methods, you don't have to remember these. Direct DNA injection, again, how in the world? Liposomes, cationic polymers, and electroporation. The other two obstacles are inadequate gene expression and unacceptable adverse effects. But both of those are down the road. If you can't get the gene in well, you're not going to have gene expression. If you don't have gene expression, you don't have to worry about adverse effects. So if the biggest problem is getting it in, and that's where they're struggling with it, the technology just has not yet caught up entirely with what we would like to see accomplished. So that's going to keep happening in your lifetime. It's happening now. There's people doing research on this over at OUHSC, and we'll see what comes of it. Okay, which brings us up to ethics. The video clip will not run. It was actually kind of interesting. It was about Angelina Jolie. And they were doing a little news feature on Angelina Jolie. And y'all know what Angelina Jolie did. She had radical bilateral mastectomy. She had all of her breast tissue removed because she had a genetic variant that was most likely predictive of getting breast cancer. I think they quoted in the thing here was like an 87% chance of developing breast cancer at some point down the road. So she had that done. And it was such a big deal for her because she's just this gorgeous person, with this very athletic trim body that the world just jumps all over a story like that. So that's what it was. And that was kind of the open to it. So my question to you is this. And you're going to have to kind of commit yourself one way or the other. If you could know your genetic makeup, your genome, and what that genome predicted for you in the future, would you want that to be known?
Yes.
Okay, let me just do a show of hands. How many people would want to know their sum total makeup and what that predicted? Okay, well there's more than you might think. Who would not want to know what their makeup was and with predictions of what could happen? Okay, you're kind of on the fence. Okay, let's go this direction. If you want to know, tell me why you want to know.
Because I want to know what I'm going to be predisposed to and what my kids are going to be predisposed to so that we can fix it.
Plan for it or fix
Yeah.
it? Okay. Okay. Others?
Yeah, similar to that, like I found out I had a, genetic enzyme deficiency with folate, and it's like, oh, I have to take this special form of folate and I don't have fatigue. So why would you not want to know that to not have fatigue?
So that's a benefit.
Yeah.
Okay. Olivia?
I was going to say I'm too much of a control freak. Like, I want to know everything,
So you're a what then?
too much of a control freak.
Okay, you're a control freak, so you want to know what's happening so you can manage it or deal with it.
Yeah, like you saying, I'd want to know if there's something I could prevent.
Okay.
If you can't prevent, then you can deal with it.
Mitigate.
Right, or like prepare for it, I guess.
Okay.
I think it just keeps you I'll make you overly conscious, but if I know that I'm predisposed to having a heart attack in my 60s, then when I start feeling chest pains in my 50s, I'm like, oh my gosh, is this gonna happen? And then it's not, I feel oftentimes chest pains oh, it's just heartburn, it's no big deal. But then if I know that this is possible, then I'll be like, okay, this could be real. Let's go get things checked and see what I need to do in my life.
Okay. So, and with a disease like that, there are things you can do to alter odds more in your favor. You can tilt things in your favor.
I think my control problem is why I'm not sure I want to know, because what if you find out about something and there's nothing you can do about it, and now I spend the rest of my life worrying about something that
What if you knew that you were moving towards Alzheimer's? Okay, say that.
He said, just enjoy your time while you have it.
Okay.
You can't stop it.
Oh, at this age, you're probably gonna develop it. I just want to be able to live my life and not know, and whatever happens, happens. I'm gonna live my life. I'm gonna be a healthcare provider. I'm gonna be a healthy overall individual anyway. I'm aware of all these risks that we have every day. I mean, it's a miracle that we're all even sitting here and not on a puddle on the floor. There's so many things that could go wrong.
I'm so glad I'm not.
There's so many things that could go wrong that I would rather be blissfully unaware and just do the best I can
on a day-to-day basis than have like this impending doom that I'm like worried about.
Okay, so it really gets into kind of philosophy of life. Okay. I mean, it does. There's a big philosophical element. It's like,
I think both sides might help with knowing is power, but also can be scary. And my consideration is knowing maybe what inheritance you would pass on. There's power there. And even if you have something that's really dangerous with your partner, maybe it's not something you want to pass on to another friend.
well, like Huntington's disease, I can know that, and you can know who's carrying and what the likelihood of children. I mean, you can know things like that and make to.
I feel like that also, like, we look about it in like a really dramatic manner, but like simply just knowing that you are like predisposed to having like celiac disease and just being able to change your diet from that, knowing that like, hey, like my stomach's been hurting, like, oh, I already know, you know, like this is within my genome. Then it's like, those are like the little small things that are like very helpful in life, you know? And I think it's not as hindering, it's actually very empowering to know those kind of things.
I don't know, as someone who actually could potentially do that, I don't want to cut out bread from my diet.
You don't want to know that. Okay. There's.
I guess I'm the opposite because like I have that, and had I known that when I was little, I would not have been sick like for like 23 years of my life. Had I known early on that I shouldn't be.
Same with me, I have celiac too, and it's like, I would never go back to bread, like, couldn't. And I used to be the same way, like pasta, bread, man, loved it. And now it just scared me. Like,
So y'all have already y'all have identified two of the biggest issues. Is there are some benefits definitely from knowing, because there are diseases and predispositions that can be dealt with and managed earlier and predicted. That's helpful. And then there's some other things that can happen that there's no way to manage those things. And then if you're the type of person who knows it's looming in your future, how does that affect every day up until that day that begins to be more of a problem? And so you kind of have to make choices for yourself. Are there any other perspectives on it? Because there's no right answer here. It's not like all right and all wrong to know things or not. We have knowledge. There's no reason not to use knowledge when you can use it positively. When you start looking at knowledge for an entire population, then what do you want to get into? You know, what if the government wanted to check us all so that they all knew what was out there? Would you be in favor of that?
No.
Okay, well, that starts to get buggy, but let me tell you, I'm going to just take y'all from a first approach to let's go on over here.
way back to Hitler's eugenics.
Yeah.
Absolutely, you know, there's stuff, okay.
And the like design a baby thing that people talk about now for the, you know, in vitro, that you can choose features and
Yes.
it just gets,
Or
Yes.
escalates quickly.
Yes.
Insurance company.
Yeah, that's cool.
Yes. Yes, what about that whole insurance company issue? You know, that could be there. Do you think somebody should be mandated to have genetic information done?
No, but I think if you want to, you should be able to do it.
Yeah, I don't disagree with that, you know, but it starts to become societal. What if we knew that we could predict people who were gonna have expensive diseases? Couldn't we use our resources better? Is that a good thing or a bad thing?
No, but honestly, I think people would waste money.
Do you think what now?
I feel like people who are greedy would be like, you're gonna get this, I'm gonna treat you for a long time and waste a bunch of money.
Profit from it.
They would take advantage of it. Or
People-
people being discriminated for whatever they have.
Absolutely, there could be discrimination.
Even if they hire a job, like if you know they're gonna die before they can retire, then you know.
Well, you know, these are all things to look at, but that is true. Wherever there is good that can come out of information, there's bad that can use that same information. As long as human beings are human, you're going to have this issue of how will information be used. You know, it can all be used for the good or it can be used for the bad. But let's say that, you know, somebody does have some genetic something that is going to impact the way their life runs or the way you're going to have to spend money because of your relationship with that person. Then there are going to be those who start being biased against you, very subtly pushing you in directions, doing things. We have to have 5 layoffs this week, so who's it going to be? Well, I got Mr. So-and-so who's going to end up with so-and-so cancer, and that's probably going to cost our company this much in health insurance over the course of a lot of years. So, you, without saying it, will just say you're not a good performer. But how do you know that up underneath that decision about not being a good performer is the fact that you're going to cost them $1 million, and then they shuffle you off? And I'm just saying, this is human beings. Again, I'm not against people. I love people, but humans, okay, there's stuff in there.
Oh man, that's really interesting what you just pointed out. I was just thinking, that being said, I mean, we express our genetics through our phenotypic experience all the time. So, I mean, you know, if, yeah, sure, it exposes them to certain information as an employer, like, yeah, this person may cost me money, but, I mean, we already make decisions based on that, just looking at people every day. So, I mean, what's the opposite of that? Would you just, everyone comes in a mask every day so that you can't see what that person looks like? You know, there's no way to completely hide it anyway, so I'm curious what that information would do.
That's a good question. Like, how much information is yours alone to decide about, and how much is the world and the world's right to get into your business? Now, we got HIPAA. You can't get into people's records and just shuffle stuff around. But if you're a healthcare provider, you do know stuff. And you know stuff gets around. Okay? Even with HIPAA, stuff can get around among people. I don't know. It gets to be a little bit sticky, so when you're looking at pharmacogenetics, same thing. What if you can test people for positive responsiveness, but also by testing it, you know who's going to be a negative responder? You then pull back hope off of that group of people because there's nothing for them versus those who could benefit. So from an economic standpoint, you can spend your limited resources better for the people who respond the best. But when you do that, you are also telling other people, I'm sorry, we don't have anything for you, and we have things for them. Now, from an efficiency standpoint, I can get that. But from a human standpoint, does that impact their right in any way? Does that impact their life in any way? Well, I'd say it probably does. Now, what value does that have? That's kind of what you get into. So let me see here. On this ethical this deal about genetic testing, Professor Roy, did y'all talk about testing a little bit yesterday? You told me you talked about, so he's talked about just that it exists out there?
And which diseases it's available for.
Okay,
Cancer syndrome.
Thanks for that. But you can do this testing, but it can also, as y'all said, it can cause emotional distress. If you're a person who would know something and it would bother you because that's the way you're constituted, then maybe you don't need to know that. On the other hand, if knowledge gives you a comfort so that you can manage and plan, and you're very pragmatic, then there's a rationale to do that too. But it can lead to discrimination. So there are, you know, pharmacogenetic testing is available also. I told you there are companies now that will do pharmacogenetic panels for people. You can send it off, just like now you can send off blood to Cleveland clinics and get an elaborate profile for cardiac risk. It goes into markers for inflammation, as well as levels of cholesterol that you don't get on normal tests, like a normal lipid profile, total cholesterol, LDL, HDL, and triglycerides. That's the normal thing that you get out of labs. Okay, if you go to Cleveland Clinic, and it may not be reimbursable by your insurance because they all won't do that, then you can get small, dense LDL, fluffy, puffy LDL that's not so dense. One's more predictive than the other. You can get into apolipoproteins and all the risk that goes with them. You can get into myeloperoxidase and issues of inflammation. There's a lot of things you can get. Okay, I'll pay for that because I want to know that. That's me. I want to know that because there's things I can do in life to modify that. But does everybody have to get that? That then starts to change the equation of what your insurers know about you. Will insurers honor and respect the privacy of people, or will they look at mass amounts of data to make decisions about coverage and rates? Well, I'll tell you what they're going to do. They're going to take massive amounts of information, de-identified, and make decisions about rates and coverage. They always do. Okay, and I hate it, okay, and you will come to hate some parts of that kind of stuff too, but that is a reality, okay? So it's not, the ethical decisions about pharmacogenetic testing are not a big deal when you've got a wide variety of possibilities. Like number one, it's not of significant ethical consequence. There are many options for treatment, like blood pressure response to beta blockers. You got a bunch of beta blockers, you got other drugs. If you can pharmacogenetic test to figure out which categories are not of any value, then you don't waste time, you don't risk people for adverse effects, you just go to the thing that's going to be a benefit and then manage it to the best level that you can. That's not a big issue. But let's say there's a cancer therapy and one person is going to respond and one person's not going to respond, and if you're a non-responder, you're dead. That means you're dead. Then what do? Do you just go to hospice? Do you just shut down? I don't know. There's an issue embedded in pulling hope off of people and sorting people out, because if you're one of the outcasts, do they then come back and work on treatments for that group of people, or do they just put all their money into the ones they know they can fix while some researcher probes around for some possible treatment for this other group? And what if the other group is always a minority and the biggest group is the majority? Is there any incentive to develop a treatment for the people who are in the minority? Or do you just get the death sentence and nobody's going to do research for you because it'll be a 10% group of this cancer all the time? We'll just let that group go. If you're in the 90%, good for you. If you're in the 10%, you're dead. That's kind of the odds. That's the breaks. Does medicine do that to people?
Yes.
Should it? I mean, does it? Yes. Should it? I don't know.
There's that cancer, it's like PI, PG or something, it's that 100% fatal in children, and it's so rare that they really don't put the money into any treatments. But if your kid has it, then you die. It's just
if these decisions make sense in mass, but they don't make sense for individuals. You are learning how to be a healthcare provider for a person, and your job is to be invested in helping that person achieve the health that they want to achieve. Other people can stand back here and look at the mass of things, but it will be difficult for you to be a very effective clinician, patient by patient, if you operate in a population manner with a callousness when things can't work. I don't think that's what people want you to be. So you'll be torn, because when you go home and look at things on the big picture, you can understand that. But then when you open that door to that patient's in there, you're in a different zone. Because I do it myself now. I can talk about masses in the population and what people do and don't do and why we have to pay rates for this and people don't modify their behaviors, they have terrible lifestyles, and we're all having to pay this much more money every month because of that. Okay, that's one thing. But then when I'm in there with the person who's doing those things, I'm just kind of going to grind it out with them in the road to figure out what they can do and try to help them lean in the right direction. So it's like that role, one-on-one is one role, standing back is another role. You cannot have stand back role in the room with the patient. And so you will be conflicted, and you will have different hats on different days. Welcome to the world. Welcome to the world. That's just kind of the way it is. And as a healthcare provider, you have to play both, but at the right time. Now, there is a genetic law. A genetic law was passed called GINA, G-I-N-A, the acronym, Genetic Information Non-Discrimination Act. It came about in 2008. It was one of the last things that George W. Bush signed before he went out, was this GINA thing, because so much of the human genome was finished in 2002, 2003, and stuff was turning up. And 6 years later, people began to figure out they know stuff. What are they going to do with that? Are they going to hurt me? Do I trust the world? Or do I need the law to protect me against the world? So what it did is it was intended to prohibit an insurance provider or an employer from discriminating against an individual based on genetic information. So the thing that we're worried about, it was directed to them to make them not do that. It was, like if you knew somebody was a cancer risk, would you insure them or would you make their rates higher because of a significant potential in the future? Is it a 100% genetic guarantee or is it an 80% genetic guarantee? All of these things are not 100%, believe it or not. Now some are, but a lot of them are not. But if you have them, like Angelina Jolie, 87% chance you're going to have cancer, 13% chance you're not. Okay, she decided to play the odds 87% you will and not roll the dice on the 13% that she would not. Will an insurance company decide that when it's something like that, well, I'm just sorry, even though you have a 13% chance not, you just have to pay the money because that's the breaks for you. Okay, so you can see that kind of jump happening for people. And certainly employers, I'm telling you, hiring, firing, letting go, how you deal with people, there's so much stuff operating underneath visibility that this is just one more thing that can be done. I'll tell you, it happens all the time. Somebody gets older, we're just gonna move you out because you're not any good. Well, that's what, the older people actually know more, they're better, they're efficient, they know things to experience that cannot be known by somebody who's newer coming in. But a newer person coming in is a lower salary, there's less health insurance that has to be paid for that person over time. An older person has a higher salary, and they probably have their higher pension. There's lots of things that go into their overall package. So if you're trying to save money as an employer, you get rid of them and say, well, they're getting older and they're not as good as they used to be. I've seen that happen where that absolutely is not the truth, and the reason they do is because they're trying to cut their overall bottom line down. So they're manipulating for financial reasons, which is discrimination against a person on altogether phony grounds. The public story is this, the private story is something else. Okay, that happens. Again, I hate to tell y'all, but that does happen. And so you do have to have discrimination and protection. So if you have a genetic profile and they find out or know, see, I would never let an employer mandate anything off of me. Even right now, there are places that require drug screens. I understand that, and I know where that's come about. But I remember the first time I had a job. One point I worked at Oklahoma City VA, and that was in the late 80s, like 88. And you had to be drug tested before you were employed, and then randomly drug tested at any point that they wanted to down the road as a basis of employment, and in a sign you would do that. And I remember I just thought, I don't like this. I don't like this one bit. I am not using drugs. I don't want to be screened like this, and I don't think I want somebody walking up to my office one day saying, you need to go pee in a cup. If I'm not doing anything, why am I peeing in your cup? You know, so, but it's just stuff like that. That seems to me to be pretty much a violation. Now I understand the reason they do things like that is because they carry liability. What if you're impaired and you're working in healthcare and you can make a bad decision for somebody and cost them your life? Okay, I get that. So if they're smart, they will have reason for randomly testing somebody. You know, it's not like random anymore, it's like random with a reason. But I think you have to have reason to do that. Same thing for genetic testing. If you just really want to do blood samples, you know, just as a basis for how we're going to insure you, I think I would say, I'm not working here, too much of a Gestapo atmosphere. Just, it's a violation of privacy, for one. My body is my body. You hire me because of what you think I can do. You don't think I can do it, don't hire me. You don't need to know anything else. You can't see it now, you don't need to see it. My business. So, get real feisty here. Okay, the law was enacted, 3D, the law was enacted to help ease concerns about discrimination that might keep people from getting genetic tests that could benefit their health. What if you wanted to screen yourself for cardiac disease or cancer because you wanted to do that? Like, Chris, I mean, you want to do that? That's fine. But it blocks their ability to get that information or use it. I'm still just wary of the information existing. If it exists and the law says you can't know it, I still don't know that they can't get their hands on it and use some other reason to get you. Yes? Question? Okay. And then on C, on page 20, the law also enables people to take part in research studies without fear that their DNA information might be used against them by health insurance in the workplace. I've done several different drug studies, and every drug study that I did had a statement that a person could check a box that I am okay with genetic tests being done on my material, whether it's a tissue sample or a blood sample, because you draw lots of blood and urine in almost any drug study. You're doing blood and urine screening all the time, and they can run genetic tests on those folks, and that has to be approved by the person. It can't just be done and stored over here. Okay, so if you say no, they can't do your stuff. And even if they do your stuff, it can't be released to anybody, which is good. Okay, The biggest ethical concerns I told you earlier are when genetic material is inserted not into somatic cells of you, which is where the genetic experiment ends, but when it gets into germ cells and it moves to the future, because future people, you can't infringe on their rights of an altered genetic expression without their consent. Which I think kind of gets into a sticky area, because if in abortion language a person doesn't have life until a certain point, then how do the geneticists work their way back into your interfering with the rights of somebody? What if the parent says, I would abort anybody? Does that fetus have rights? And I'm not going to get into what's right or wrong with this. I'm just saying, how can they push back into, you can't use genetic material in germ, they can get into germ cells of me because it may infringe on the rights of somebody in the future, when the law right now can't even decide where life starts. So I just think it's an interesting question. I don't know. We're at a phase where law is not even caught up with what's right, and we don't even know what's right. Okay, so we're just in gray zones. Yeah.
I definitely understand like the whole ethics and everything like that, but if a child came out with a defect, doesn't the parent have the right to genetically modify their genome to fix the mutation? So isn't it kind of the same thing? Like if you fix them in the germline, then aren't you just taking responsibility for what you did? Because if they come out as a child, you still take the responsibility as a parent. So doesn't it kind of just
I hear you. I hear you. I think it's a good question. I don't know how it would be litigated in law, and I'm almost certain that the law has not encoded itself. You know, that there aren't laws. There are things out there in healthcare where there simply is not a law. We don't know what the rights are, or even what the definitions are. So I hear what you're saying. If I had a child with a genetic defect and I knew that something could happen and the genetic insertion would impact their germ cells, I, as a parent, want to have the right to make that choice for my child. Okay? I don't need a court telling me that until they're of age of consent, whether they don't live to consent, you know, what's that? So as a parent, I would be a parent. I don't want to fix them. I don't want to help them. I do what I can do. What the law says, I don't know. We might have an issue.
Do you know what the law is on that right now?
I don't. I really don't know, and I'm telling you, it's so fluid. They will have to have, you know the way law is now, you have to have a case and something happen before it defines rights. And I don't know that there is any law. I know there's GINA laws out there for what can happen. But in terms of rights of people genetically, I don't think it exists.
Because my nephews have a serious like genetic defect, and they are doing gene therapy, and they have done it in adults, and they're now moving it on to kids.
Yeah.
But they're not cognitive, and they can't speak, and so how?
There's no age of consent there.
Yeah.
Okay. It's fascinating. The whole thing's fascinating. It's okay. I think what we're going to do is application of the material. We've already seen that. We've already talked about that. And you can just take a look at the barriers to the implementation. There's 3 barriers on page 21 and 22. We've already talked about it pretty much. Knowledge barriers. What do we know? What can we do? What can we find out? The logistic barriers are more having to do with who will pay for it, where is the information stored, what decisions do we make off of it. If you know this genetic material is X, do you do this, do you do that? We don't really have all those things worked out just yet. And then evidence barriers. Even if we have genetic information, what does it mean? If you do method A, what's the percent outcome positive? We just don't know a lot of stuff. And this stuff will grow up during your practice lifetime. It will be something to work with. Key concepts just restates all the big things we've already talked about. So that's it. I'm going to let you go because you're 5 till. But thanks for the discussion about genetic testing. Just thinking about it, because we talk about all this stuff on the ground, but it's equally important to think about what does it mean? You know, what are you going to do with it when you get off into the world? So, any questions about this content? Objectives, straight down the line, know it like I've asked you to know it. If I don't ask you to know it, don't waste your time. You've heard what I need you to hear. work with it. Have a great spring break. I am looking, y'all come back and just be happy people after the test is over.
Yeah.
Okay, good luck to you.